Hello boys and girls, welcome to the Math Club. In this video, we're going to talk about Mathematics Year 9 Achievement Test, October 2021. Question 8. A group of students each took a test in maths and then a test in computing. Their scores from each of the tests are displayed on the scatter graph below. So this is the scatter graph and these are the results of these students. Now let's take a look. This is computing and this is maths. Now the question here says, another student took the maths test and scored 70 marks. What mark would this student be predicted to get on the computing test? So we're going to predict the mark of the student depending on his score in maths. Okay? Now this is a scatter graph. To use a scatter graph for predicting, we have to draw the best fit line or the line of best fit. Now let's take a look first here. We know that he got 70 in maths. This is maths. Now we're going to draw the best fit line like this, something like that, in the middle, almost in the middle between the data, because the data is everywhere. I made some of them on the top of the line, some of them are on the bottom of the line. As we said, because it's going up, the data is going up, it means this is a positive correlation, because they are forming a group which is going up or upwards. We call it a positive correlation. Now we're gonna look at the 70 mark from the maths test, because he scored 70 on maths. We're gonna come here and then we're gonna go up until the line stops us. Okay, first let's move this line. It has to be on the points themselves, not on the points, almost in the middle between the points. Yes, like this. Here we have 5, here we have almost 5. So yes, now we're gonna draw a line from the 70 until the line stops us like this. Okay, we don't go until this one. This is called an outlier. An outlier is a point which is an extreme data. It might happen because of a mistake or extreme data. Now we stopped by the line of best fit. Now we go back to the computing mark and we find out that the student got 50 on the computing mark. So this is the answer of this question. It's 50. Let's take a look at the options that we have. We have 50, so the answer is 50. Yes, that's how you answer a question like this. You have to follow the line of best fit. So draw the line of best fit and then find the maths mark, go up until the mark stops you, and you will get the answer of the question. Now let's move on to the next question. Here, let's zoom in a little bit. Yes, thank you. Okay, question 9. Write the following expression as a single power of 8. It means 8 with a power on top of it, like this. This is the meaning of a single power of 8. Now 8 power of 6 power of 3. When we have a number like this, let me zoom in so you can see it. Yes, here. This is a power of a power, a power of a power. When we have a power of a power, we just multiply the powers. That's the rule between powers. If we have a power of a power, we multiply the powers. So the power will be 6 times 3, and at the end it's going to be 8 power of 18. Power of 18. Very good. So the answer will be 8 power of 18. Now let's check if we have 8 power of 18. Yes, we do. It's answer D. So for question 9, it's D, 8 power of 18. Okay, that's the answer. As we said, if we have a power of a power, we multiply the powers by each other and we just write the number as it is, which is 8. So 8 power of 18. Okay. Now, if the numbers are added, same numbers are added, and I have powers, I just multiply. If the numbers are multiplied, I add the powers. If the same numbers are multiplied, same base numbers are multiplied, I add the powers. If the same base numbers are divided, I subtract the powers. But if I have a power of a power, I multiply the powers by each other. That's the idea of this question. Now let's move on to the next one. Question 10. If A equals 3, B equals 1, C equals 5, find the value of this. So this question is about what? It's about substitution. Substitution means what? It means take the value of the variable and put it instead of the variable. Because A equals 3, I'm going to remove this A and put 3 instead of it. So let's do this here. Let's take this space down. We already know the formula. We're going to put 3 instead of this A. So I'm going to write each number on top of it. So this is 3. And then instead of the B, I'm going to put 1. So this is 1. And because the numbers are attached to the other numbers, it means they are multiplied by them. And here the A is 3 again, here 3. And the C is 5, so 5 power of 2. Like this. Okay. So that's the idea of substitution. I'm going to take the values of variables and then substitute them instead of these variables. Now let's write the formula again as it is. So we have a bracket. Let's make it the same as it was. Bracket. We have 4 in the middle or inside multiplied by 3. So times 3. And then plus 3 multiplied by 1, which is the B. As I said, I removed the variables and put these values instead of them. And then we have power of 2 here. Power of 2. And then plus, don't forget any part of the expression. A is 3, so 3. And then multiplied by, C is 5, as we said. And then squared, 5 squared, yes. Good. Now we're going to finish each part depending on the bit mass that we talked about before. We said that bit mass means what? It means the order of operation. The order of operations. So B means brackets. So finish what's inside the bracket first. Let's finish it. 4 times 3 is 12. And then plus 3 times 1 is 3. And then this one is what? 15. Good job. And the 15 is squared, so I put squared on top of it. And then when I square the 15 using the calculator, of course I have to use a calculator, it's going to be 225. So I finished what's inside the bracket. Now I can move on to the next step. So I finished B. Now I look at the indices. Even the indices must be finished. This is an index, we did it. This is another index, let's finish it. So here we have plus 3 times 25. So I'm going to write it like this. Plus 3 times 5 squared is 25. So 3 times 25 is 75. Good. So this one is plus 75. Okay. So I finished the index or the indices. I did the division. There's no division here. And multiplying. I did the multiplying. Now I look at the addition and subtraction. Addition and subtraction. So I have this, which is 75. I have to add it to 225, which is the end result of this one. As you see, I did this alone and this alone. Don't be confused. This one, I finished it. I found it. It's 225. And this one at the end is 75. So I'm going to do add 75 plus 75. So 225 plus 75, 225 plus 75 equals 300. Equals 300. And the final answer will be 300, which is B. And this is how you answer a question like this. So first thing, you substitute the values instead of the variables, and then work out using BIDMAS the order of operations, and then at the end you find the final answer and tick it. Okay, this is how you answer question 10. Now let's move on to the next question. Question 11. work out these. These questions can be worked out using a calculator, no problem. But if they need steps, you have to follow the BIDMAS rules. And steps are needed in section B, so you have to understand how to do the steps. I'm going to answer it using steps here so you understand the idea. First, we're going to write BIDMAS to follow it, okay? First, BIDMAS. Now, do I have B, which is bracket? Yes, I do. So I'm going to finish what's inside the bracket first. I'm going to write the equation again, not the equation, the expression, 32 plus 16, and then divide 8 minus 4 equals what? Very good, equals 4. Now I finish what's inside the bracket, so I can take the bracket out or the B out. Now, do I have indices or powers? I don't have, so I take it. Do I have division? Yes, I do. This is division. So I'm going to do the division first. So I'm going to write 32 plus 16 divide 4 equals, good job, 4. Very good. Now I finished what? I finished the division. Now I'll take it. Do I have multiplying? I don't. Do I have addition? Yes, I do. It's here. So 32 plus 4 equals, very good, equals 36. And this is how you answer a question like this. So the final answer is 36. So as we said, you have to follow the rules of BIDMAS: bracket, indices, division, multiplying, addition, and subtraction. Follow these rules or order of operation, and you won't have any problems using the steps to answer a question like this. Now let's move on to the next question. Question 12. Shape ABCD is a parallelogram. Now we have ABC, we don't have the D. Now, what could the coordinates of point D be? We're trying to find D to make it a parallelogram. Let's zoom out a little bit. Yes, like this. Okay, to make this shape a parallelogram, we have to follow the rules of the parallelograms. Parallelograms look something like that, for example. Yes. The distance, let's say, use another color so I can explain, yes. This distance is the same as this distance. Okay? Same idea, this one is the same as this one. So the horizontals are the same, the vertical ones or the oblique ones are the same. Now, as we see, we have 3 points here, we're missing one. We need to find the real distance between A and B, or the distance between A and B. So the distance between A and B here, how many boxes from here? We have 1, 2, 3. So 3 boxes. And I'm counting these numbers on the x-axis, okay? I'm using the coordinates here. So these are 3. It means I need 3 boxes, same idea, to this side or this side. I can go this side because it's still a parallelogram, okay? So I have this side and this side, yes. Here. This side, yes. Because it's still a parallelogram. Even this side is a parallelogram. Yes, I can go both sides here. But I think they are talking about this side here. So I'm going to go this way. So 3 here and 3 here. It means our point is over here. So I'm going to check the coordinates of this point here. Let's make the line thin so I can work with it. The coordinates of this point, the coordinates here are -2 and yes, -2 and -1. So -2 and -1 is here. So these are the coordinates of this point. Now if I go that way, let me check if the line exists or the point exists. If I go that way, it means I have to stop here. And the coordinates here are what? 4 and -1. Do I have a 4 on the x? I don't. So this one is not the right answer, because I can go that way to make a parallelogram. It's not a big deal. It's not a problem. It's the same answer. But I don't have this point on the coordinates. So I have to go that way to use this point here, which is -1, -2, -1, which is the right answer for this question. So I made a parallelogram using the coordinates of the new point. And this is how you answer a question like this. As I said, you can go that way to make a parallelogram, but the point or the coordinate of this point doesn't exist in the answers or in the options. That's why I didn't use it and I went the opposite way. That's it for this question. Let's move on to the next question. Question 13. In question 13, which fraction is equivalent to the recurring decimal 0.246? And the 246 are recurring or repeating. So which one gives you the right answer? Now, if this one or this question comes in along in section B, for example, you have to do the steps of finding the recurring decimal fraction. Now, I'm not going to answer this using the recurring decimal fraction steps. I want to answer the question of the recurring decimal fraction in its place. So here, I'm going to show you a quick way to find which one is this one. Now, it's easy to check using the calculator. You take this number here, divide it with the calculator, and check. If it gives you the same as this, or if it gives you something like this, 0.246, with dots on top of them, or line like this, because the line means recurring or repeating, and some calculators do it, or maybe you'll find some dots like this, dot here and here, maybe 3 dots, depending on the calculator that you're using. So this is the right answer. It will give you the right answer. If you divide this, it will give you 0.246 only. It will stop. So this is not the right answer. Okay. This one, the same, it won't give you the right answer. This one, it won't give you the right answer. Because this is a recurring decimal, it means that the numbers here, they don't stop repeating. So the right answer or the correct one is this answer. And you can check using the calculator. Now, as I said in section B, if this question comes, I'll explain to you how to use the N method, or some people call it the X method, or N method, in finding recurring decimal fractions. Now, let's move on to the next question. Triangle A is enlarged to produce triangle B. So A is enlarged to produce B. It means A is the original one. Focus on this. As we can see, it means that A became smaller. A became smaller. So that's the idea of this question. Now, A became smaller. Let's study the question. What do they want? What scale factor has triangle A been enlarged by? It means what is the scale factor that we enlarged by? Now, when we look at the shape, let's first explain this here. Okay. Now, we notice that A became smaller. Becoming smaller means that what? That the scale factor is a fractional scale factor. It means it's a fractional scale factor. It means we are using a fraction. So because we're using a fraction, we're not going to use the -2 and the 2. Because the shape became smaller. That's the first thing. Now, smaller by how? Both of them have the same answer, which is half. Now, if I have one of them half and one of them third, for example, I want to check smaller by how. I'll show you how to check smaller by how. By finding one of the lines, for example, horizontal one here. This one is 2 centimeters, as you can see here, from 2 to 4. 2 centimeters. It became 1 centimeter. It became 1 centimeter. So 2 became 1, it means half of it. It means half of it. So the scale factor will be half. But now both of them are half, so I have no problem choosing between them. The only problem that I have is it negative or positive. That's the only decision I have to make. How do we know if the scale factor is positive or negative? Very good. If the shape is flipped, or upside down, it means that the scale factor is negative. So negative scale factors means what? It means the shape will become upside down. The shape will become upside down. If the shape is the same, like this, for example, let's say the shape is like this. The same orientation as the original one, it means the scale factor is positive. But here, it's flipped, it's upside down. It means that the scale factor is negative. That's the idea of choosing between scale factors of enlargement. As we said, scale factor means what? It means the number that we enlarge shapes by. So we found out that this shape became half of its original one. So the scale will be half because it's smaller. And it's negative because it's upside down. That's the idea of answering a question like this. Now, let's move on to the next question. Question 15. Let's cover this. Okay. I want you to focus on question 15 because it's very important. Let me zoom in because I have space here. Yes. Okay, I do have space. Good. Let me use this shape to cover this so we can work here. Now, the distance that an athlete runs is given as 9 kilometers to the nearest meter. What is the minimum distance that the athlete must have run? Now, minimum distance means what? It means we need the upper and lower bounds. Upper and lower bounds. Because they call them minimum distance, maximum distance, the upper bound, the lower bound. They have different names. So you have to focus on understanding all the names that you have. Now, we're going to answer this question and we're going to find the minimum distance, which is the lower bound of the athlete that has to run. Now, the distance, we said it's 9 kilometers, and they need it to the nearest meter. To the nearest meter. It means we have to make it meters, and then round it to the nearest meter, or find the lower bound to the nearest meter, and then take it back to kilometers. Let's do that step by step. So 9 kilometers first equals what? How many meters? 1 kilometer equals 1,000 meters. So 9 kilometers, 9,000 meters. Good job. So this is the first step. We make it meters. Now we need it to the nearest meter. Where's the nearest meter here? Or where's the meter? Very good. It's here. This is the meter. Now we put 1 under it because it's only nearest meter. Not nearest 10 meters, it's nearest meter. And then we divide this 1 by 2. Focus on the steps. These are the steps of the upper and lower bound. Now 1 divided 2 equals what? Very good. Equals 0.5. 0.5. Good job. Now we take the 0.5 here because we're trying to find the minimum distance. It's the lower bound. Lower bound means subtraction. If we want to find the upper bound, we're going to do addition. But here we're trying to find the lower bound. So we're going to subtract it from 9,000. So we're going to say 9,000 minus 0.5. You can use a calculator for this. So 9,000 minus 0.5. It will give you 8999.5. 8999.5. In what? In meters. In meters. Good. So we have 8999.5. This is the lower bound in meters, or the minimum distance in meters. Now we need it in kilometers because all of the answers are in kilometers. How do we turn meters into kilometers? First, how many meters in a kilometer? Very good. We have 1,000. So we say 1 kilometer. Let's do it here. You want to understand how we turn 1 kilometer equals 1,000 meters. Now here, these are meters, so I'm going to put them under the meters, and I'm going to put a question mark here. Question mark kilometers equals 8999.5 meters. We're going to use the X method here. As we learned, the X method is used to solve a lot of problems. We put X in the middle. We multiply the ones which are attached with one line. These ones, they are attached with one line, and both of them are numbers. I can't multiply these because I don't know this. So I'm going to multiply these and then divide them by the other one which I didn't use. So I'm going to take 8,999.5, multiply it by 1, which is the same, and then divide it on 1,000. So I can divide it on 1,000 directly because 1 makes it the same. So 8,999.5 divide 1,000. And the answer will be 8.9995. So the answer will be 8.39123 and a 5 kilometers. And this is the final answer, or the minimum distance, or the minimum bound that the athlete must have run. So the final answer is D. And this is how you answer a question like this. Now, let's remember the steps together. First thing we did, we turned this into meters. Why did we turn it into meters? Because they said the nearest meter. I have to follow the rules of the upper and lower bound. Now, we turned it into meters. We found the nearest meter, which is 1. Divided by 2, it's 0.5. We subtracted from 9,000 because they want the minimum distance. And we got 8,999.5 meters. Now we turned this meter into kilometers by using the X method. We got 8.9995 kilometers. And this is how you answer a question like this. Thank you very much for watching. See you next time.